Hello and welcome to this video from Heybridge High School and Sixth Form Maths Department. This video covers the GCSE higher tier topic of expressing recurring decimals as fractions. So we're going to begin by looking at a fairly simple example. We're going to express 0.7 recurring as a fraction in its simplest form. So we begin by putting the recurring decimal as equal to a variable. So I'm going to use x. And I'm going to put that equal to 0.7 recurring, but I'm going to expand the decimal. So I'm going to write out the recurring group a few times so that I can see what it looks like, because that will then make it easier for me to see what I need to do next. So my recurring group is 1 digit long. So I'm going to multiply both sides of this equation that I've formed by 10 to the power of the recurring group. So in this case, it's going to be 10 to the power of 1, which is just 10. So x times 10 will give me 10x. And 0.7 recurring multiplied by 10 will give me 7.7 recurring. I'm now going to find the difference between these two equations. So I'm going to subtract the first one from the second one. So 10x take away x will give me 9x. And 7.7 recurring take away 0.7 recurring will give me 7. And I've now got a nice simple linear equation which I'm going to solve. So I'm going to divide both sides by 9. And that will give me x equals 7 over 9. And since x equals 0.7 recurring and x equals 7 over 9, then 0.7 recurring expressed as a fraction is 7 over 9, and we can't simplify that because 7 and 9 have no common factors, so that is 0.7 recurring as a fraction in its simplest form. We're now going to move on to a second example. So this one is asking us to express 0.81 recurring as a fraction in its simplest form. So I'm going to follow through the steps again. So I'm going to start off by putting the recurring decimal as equal to a variable x, and I'm going to expand it so that I can see what the recurring group looks like. So this time my recurring group is 2 digits long. So I'm going to multiply both sides of my equation by 10 to the power of 2, which is 100. So x times 100 is 100x. And 0.81 recurring times 100 is going to be 81.81 recurring. Then I'm going to find the difference again. So I'm going to subtract the first equation from the second. So 100x take away x is 99x. And 81.81 recurring take away 0.81 recurring will give me 81. And then I'm going to divide both sides by 99 so that I can find the value of x. So I will have x equals 81 over 99. Now, the question asks for the recurring decimal to be expressed as a fraction in its simplest form. And if I have a look at 81 and 99, I've got a common factor here. I can divide them both by 9. So 81 divided by 9 is 9, and 99 divided by 9 is 11. And I can't simplify that any further because 9 and 11 have no common factors. So 0.81 recurring as a fraction in its simplest form is 9 over 11. So example 3, express 0.623 recurring as a fraction in its simplest form. So again, just follow through the steps. So I'm going to put x is equal to 0.623 recurring. My recurring group is 3 digits long, so I'm going to multiply both sides of my equation by 10 to the power of 3, which is 1,000. So x multiplied by 1,000 is 1,000x, and 0.623 recurring multiplied by 1,000 is 623.623 recurring. Again, I'm going to find the difference, so I'm going to take the first equation away from the second one. So 1000x take away x is 999x, and 623.623 recurring take away 0.623 recurring is going to be 623. Now I'm going to divide both sides by 999. And that will give me x equals 623 over 999. And this can't be simplified, so 0.623 as a fraction in its simplest form is 623 over 999. Now sometimes you might come across a question where you've got some digits that don't recur that come before your recurring group. So the first thing that we're going to do is the same thing that we always do. We're going to put this as equal to x. So x equals 0.374 recurring. So the first thing that I want to do is I want to get that 3 on the left hand side of the decimal point, because I need two numbers that have the recurring group only to the right hand side of the decimal point. So I've got one digit that doesn't recur, so I'm going to multiply both sides by 10 to get that digit onto the left hand side of the decimal point. So if I do x times 10, I'm going to get 10x, and then I'm going to multiply 0.374 recurring by 10, and that's going to give me 3.74 recurring. Now I need to multiply that 10x equals 3.74 recurring by 10 to the power of the recurring group, and I'm then going to have my two numbers that have got the recurring group to the right hand side of the decimal point, so I can then eliminate that recurring group. So my recurring group is 2 digits long, so I'm going to multiply both sides by 100. So 10x times 100 will give me 1000x. And 3.74 recurring is going to give me 374.74 recurring. Now this time, I need to find the difference between the two equations that both have the recurring group only to the right hand side of the decimal point. So I'm going to find the difference between 1000x and 10x. So 1000x take away 10x will give me 990x. And 374.74 recurring take away 3.74 recurring will give me 371. And then I'm going to divide both sides by 990. And that's going to give me x equals 371 over 990. And again, that one won't simplify, so 0.374 recurring as a fraction in its simplest form is 371 over 990.